finalists. So second, we come to our Italian champion, Marco Ferrigo, a student of mathematics at the University of Pisa, where he's developing an analytical model for the evolution of tumorous cells. We're not trying to find answers to cancers. Marco attempts to make various mathematical concepts fun and interactive for children and adults via exhibitions, workshops, games, and now, of course, via FameLab 2. He should be ready as his 3 minutes are about to start. So, on your Marcos, get set, Ferrigo.
The flap of a butterfly's wings in Brazil can set off a tornado in Texas. What is the mathematics behind this catchy phrase? To find out, I will describe to you an experiment that, yes, you may try at home. This experiment involves the typical mathematical tool, soap bubbles. And the first part of the experiment is extremely simple. Just blow your bubbles and watch carefully at the outcome. So, count how many bubbles form, where they go, and how long they live. The second part of the experiment is a challenge. Try to reproduce exactly the same bubble behavior. Okay? What can you do to do that? You can try to reproduce exactly the same initial conditions. So you will stand in exactly the same spot, put your stick at exactly the same height, and use the same blow intensity. But when you try yourself, you will find out that any shot is completely different from the others. And after a couple of seconds, the bubble behavior is completely unpredictable. What happens is that the first and the second shot follow a similar path for a couple of seconds, but then some small differences in the initial conditions, such as a different inclination of your stick, of your blow intensity, have time to evolve and unbiggen and result in totally different outcomes. This experiment shows us how the meteorologist's work is done. A meteorologist collects data about air pressure, air density, wind intensity, puts them in powerful computers where sophisticated mathematical models reproduce the interaction between atmospherical agents. The result of such a computation is that accelerated multimedial version of reality you see when you watch weather forecast programs on the internet or on TV. But again, what happens here is that reality and its simulation can follow a similar path just for a certain amount of time, and then some small differences in the initial conditions which I measured have time to evolve and unbiggen and result in totally different outcomes. And that is how the small differences made by the flight of a small butterfly, if not specifically measured, can end up in an unpredictable, unpredicted tornado. With modern technologies and mathematical models, the edge of predictable is about 48 hours. But how far can this edge be pushed? Well, this is a really difficult prediction to make. Thank you. Whew. Okay, here I am.
I love the way you used sort of everyday and very familiar things to draw people into what is actually some very complicated science. How easy did you find it to, because obviously you started off with the butterfly effect, but just to work on the analogy and then to decide to use the bubbles?
Well, actually, the analogy is well studied. I mean, I just had to find an example of a complex system, so of a highly non-linear differential equation system, and of course, anyone will think of soap bubbles. No, but anyway, it's quite studied. It's well known that soap bubbles are an example of the butterfly effect.
Was it Maynard Smith who said that modelling is doomed to succeed? What do you feel about that comment?
I don't know. I didn't understand the question, sorry.
If modelling, because some people just don't believe computer models. Oh. And yeah, I know it's amazing, because I use a lot of modelling in my work, and it's quite depressing. But what is your answer to someone who says, oh, it's a computer model?
Well, you just
how can you validate it?
You just show them they work.
So how do you validate your model? What might you use to show, for instance, the elegant complexities of weather with these multiple parameters going on? How can you actually validate, show that your model can produce a predictable, even if it's within 48 hours of an event, how could you validate your model was correct?
Well, first of all, by showing how it works. I mean, showing the outcomes and showing, well, look, I will now make prediction for the weather for the next 2 days, and then we'll check together if it works, which is what scientists actually do. So it's always a matter of involving the people in what you actually do that convinces them of the goodness of your work. Another way would be to explain why you chose some parameters, why you give some weight to other parameters, and this could be possible. It's more difficult, that's for sure, but maybe more interesting, and this is what we do, what we are interested in, so also that will be possible.
Further research needed. He's managed to soft soap the judges. Please thank Marco Ferrigo.